There we go. So now the video is running. I will also generally record things, although I'm not going to lecture a lot this summer quarter because it's a hybrid, because we've only got one day in class, because there's a lot of stuff to do, which you could probably do at home, but if you want to work here, I want to give you the time to do that. So I'll probably create more videos, and they'll be a little bit better than the videos that are on there right now, because they won't happen in live class. If you've watched my videos before, they're full of, oh, let me, the long dead spots while I go help somebody, and they're full of debugging and stuff like that. Generally, when I make them by myself, they're a lot shorter, a lot fewer gaps, and if I really screw up, I just erase it and do it again, which is good and bad. Sometimes it's useful to watch me screw up, I think, to see how you get out of it. So I will make more videos. I'll also do some links, and if you need more, just let me know. I'll try. As I said, I've never taught this as a hybrid, and I've never taught it as a summer course before, so we'll be learning a little bit together. I do like the hybrid idea in the sense that we only have to meet once a week, and it gives the summer a little bit more openness if you need to do other stuff. Anyway, so blogs, YouTube, and I'll also try to attach some other stuff as we go through. Questions on that? And if you want books, I can suggest books. We're going to focus on just one piece of systems analysis. We're not going to do it all. So most of you know me. I see only like one person that may not know me. My office is right across the hall. My email is the same as everybody else's, stephenconger@seattlecolleges.edu. The only thing that confuses people is I usually go by Steve, and that won't work on the email. It uses the Stephen. My website isn't particularly relevant here. I will show it. So it has sample syllabi of my other courses, which need to be updated because they're all kind of, I'm not good at keeping this up to date. But it's there. There's another link to the blog. I'm not sure why there's a link up at the top end there, but there is. So we're going to talk about what systems are. We're going to talk about some different methods. One of the things that I'm going to do, which you will hate me for, is I'm going to have you guys do some reports on some of the other aspects of systems analysis that we're not covering directly. So one of the things that will happen in class is we will schedule a few presentations. This is a much smaller class. Last time it was like 32 people. So the groups, probably not everything will get covered. I'll try to cover some of the stuff that doesn't get covered. We'll talk about that a little bit more because I'm going to focus on the part that interests me, which is not, and I think that's most relevant, which is we're going to talk about universal modeling language. We're going to diagram, the things like use cases. I'll show you some examples in a few minutes. So use cases are like in Agile, they'd be the stories. If you've done the Agile stuff, they're basically how would a user use this software? What are the use cases for this user? What are the use cases for this user? How do they interact with the software? It's really useful to know that. And it's really useful to get beyond the perspective of the coder to see how everybody else will interact with the software. We'll also do activity diagrams, which are a lot like flowcharts. They're as close as UML gets to flowcharts. And we'll look at class diagrams, which you've probably seen before. Class diagrams detail what the objects are that are in your, and we'll talk about object-oriented principles a little bit too, but what the objects are that are in your system. And we'll talk about how those objects relate to each other. There are really 4 specific ways that objects can relate to each other. And then we'll do a little bit of coding. So we will code a few things. I will help you with that. One of the problems with this class is that the coding experience tends to be all over the place. And I'm not asking you to write the application. I'm asking you to create a couple of classes and that resemble what you diagrammed. I'm not going to ask you to write the whole app. Might be fun. I've had people write the whole app because they want to, and you're welcome to. And then we're going to do some testing, because, and this will be formal testing, unit testing, just because that's actually, typically if you're going into programming, your first job out there will probably be just unit testing other people's code. And I'll show you a little bit what that looks like in Python. You can do it in Java too, and you can do it in C#. They all have libraries that will let you unit test. And it's kind of fun, kind of a pain too. And then the groups would be for the presentations, although if you really must do an individual, I'll probably let you because the class is so small. But it would be, I think it's usually better in groups. And I will give group time because we have lab time. You can use some of that time to work in the groups. You could also, if you're using Google Docs or something like that, you can work remotely with each other if you need to. Okay, so we will go without a book, it says. I have some old things here. I will real quickly click on these. I didn't remove them, but they're not as relevant as the ones were. But systems analysis, these are from the blog. I just wanted to say a definition of a system and analysis and then what they are together. So a system is a collection of things that work together to achieve some kind of end. And that's basically the definition of a system. A computer is a system, a network, a piece of software, you know, production line. There's lots of things. Systems analysis is actually applied to a lot of things, not just computer software building. Right? It's basically any, if you were going to design a new metro system for the city, it would go through a systems analysis process. Does that make sense? Part of it might be software, but there would be a lot of other things involved too. Analysis is where you break things apart. So one of the things, in order to understand how a system works, you need to know what its pieces are. So you need to go in and be able to figure out what the discrete pieces are that are working towards this end. And then systems analysis is basically breaking things into their parts to understand how each part contributes to the whole. And then there's a lot of techniques for doing this, and a lot of techniques for how to monitor and watch yourself as you do it so that you're not cheating. I mean, it's so easy to just want to code and not think about why you're coding it and what you're doing. This is a traditional life cycle. If you do some of the reports are on like Agile and DevOps. This gets modified a little bit, but it's almost always a continuous. There's usually a planning stage where you figure out something needs to be done. Usually you start planning when the current systems are not working or you're building something brand new, right? Your current systems are kind of kludgy or they're not competing well enough anymore. Then you can go, you know, you figure out why you need a new system. So you have meetings about, yeah, we need to get this going and whatever. Then you do a design. And some of the things is like Agile and DevOps, a lot of these things happen somewhat simultaneously, but they're still somewhat the same pattern. Design is what we're going to kind of focus on mostly, where you figure out the components, you figure out the use cases, you figure out the flow of things, you figure out how things relate to each other, what the components are. That's where we're going to focus, right? Again, it's only a small piece of this. And then you implement it, which means you deploy it. You know, you put it out there. Presumably, you've tested it before you put it out there. And then you maintain it, because as things go on, you'll discover things that need to be added or removed, things that need to be changed. At a certain point, all of that will become so kludgy you have to start over. So it goes on and on and on. Does that make sense? That's a traditional life cycle. As I said, it should be noted that these sections are not as discrete as they appear. All right, so you could look at these, but as I said, they're not as I would update them, I think. So all of the assignments will be in the Canvas, and I'll show you kind of what we'll be doing in just a second. Same thing as the outcomes above. We're kind of overview. We'll talk about these things I'm going to do. People will do these three as reports. I will do the object-oriented concepts. I'll talk about UML, and I'm going to show you UML in just a minute so you know what it looks like. And then we'll do some simple coding, and we'll test it. Questions on any of that? You can always stop me when you. Okay. So I say attendance is useful. This summer, it's up to you, but it'd be nice if you show up at least for reports, I guess, presentations. I suppose they could be done remotely, but it's a little more complicated. Generally, for every assignment, there's a rubric, and I will, if I take any points off, I'll make a comment. And you can always redo the assignment to get the points back, okay? So there's no reason. The grade is done entirely on the assignments pretty much, so if you do everything, you should get a really good grade, right? And if I do take points off, you can always redo it to fix it. And I will never take points off without a comment. If, and this happens sometimes, if you have an assignment and it's missing some points and there is no comment, that's because I made a typo. Tell me and I'll fix it, right? Because if I don't comment, then the points should have been there. That makes sense? I've done it before when you're doing Canvas in the morning with your coffee and you're just typing in numbers. It's easy to screw up sometimes. I usually don't grade with a beer, so you can be glad about that, I guess. At the bottom of this, there's a bunch of information that basically I have to confess I just cut and pasted. But there's a land acknowledgement. I have mixed feelings about those, but I won't go into that. Title 9, equity, statement from the president and civic engagement, emergency preparedness, building evacuation. Hopefully we won't have to do that. Americans with Disability Act, student complaints. So there's a lot of information down here anyway. And I did post it there because I think that it's useful to have that information. Questions on any of that part so far? Yeah.
I do have to work, and I'll probably have to work forever until I get a new job. So I just enrolled in this class because I don't have much of a choice. Is there a way to attend the presentations? Like, So
if you could do it remotely, or you could do it individually if you want.
Okay.
And if you can't present, you could just show me the presentation. Give me the presentation. I can present it for you, I guess, if you can't be here.
Okay.
Does anyone else have? I mean, I understand. You might have the.
So emailing you is the best way to contact you?
Probably, yes. I'm not super good at phone calls responding. I try. Although actually the new phone system puts the voice recording as a email, so that's always nice. Emails are the best way to contact me. And I shouldn't, but I do look at emails over the weekend and through the week. I usually check the mail at least 2 or 3 times a day. So if you have a question, you're welcome to ask it. Just know that the answer may be a couple hours down the line. The other thing that I'm thinking of, if it's a technical question, within Canvas, there are some abilities to have like discussions, and I mean, basically you could ask the class, you know, and then if they don't give you an answer, I mean, so I would also try to weigh in, but it might be better than just asking me, particularly if you're having a problem. I get a lot of requests to remote debug, and with not enough information to do so. With like a piece of code or an error message without any context, you know, sometimes I can do it because I've seen enough of them that I can guess, but sometimes a lot of times I can't. we're not doing a lot of, there shouldn't be a lot of that kind of thing until the very end when we do a little bit of coding, but even then the coding won't be that intense. So anyway, short answer, yes, email's best. What else do we have down here? So let's look, I guess what I'll do first, so we'll look at the assignments, and then we'll look at some of the tools that we're going to use, which are not that extensive for this. We don't have like a virtual machine or anything. We don't need that. So I'm going to go to modules rather than just straight assignments. Oh, and let me real quickly change this, because my view is not your view. So I'm going to go way down and do, where is the settings? I did settings, I thought. I want, it's not what I want. I want the student view of this. Let's go home. Settings, that's where I was, all right.
It was there for a second, and then it disappeared.
The student view?
Yeah, I saw it as when you clicked on that, it had like a list of stuff, but then that got replaced by this.
Yeah, why?
What about sections?
Well, it shouldn't be sections. Announcements, home.
See how there's the panels,
Uh,
the tabs. There's like tab views there.
yeah, I don't think. Well,
Oh,
actually, there it is, student view. Thank you. That's different than it was yesterday. That's strange. Anyway, let's go to modules now. The reason I wanted to go to student view is that my view is very different than yours, and it has tons of stuff there that you don't have. All right, so are these in order? We have requirements, which are use cases, process activity, overview. There's one assignment that I don't have up there, it looks like. I may have to add that. But anyway, I've tried to break these up, and I will try to add, as I make videos, I will try to add links to the modules so that you have the videos. I'll try to start making the videos this week, particularly for the use cases, although that's actually not the first assignment. There's requirements or use cases, process or activity. I'll show you those in a moment. Then there's a couple of class diagrams. I do have a couple of links for those. Then we'll do sequence and then a little coding and testing. There's also a midterm and final, couple of things about those. They're multiple choice. They are 3 tries with 4 answers. Right? So you should be able to, they're open book. They're really just meant to reinforce some of the concepts. Right? So they're not meant to create a grade curve. They're just meant to give you a reinforcement of what we've covered. And you should be able to get everything right on them. Couple of things. I think the midterm is ready to go. Let me look at it. The final certainly isn't. I need to work on that a little bit because I think the examples are in Java, and I want to change them to Python. So those will be that. The first assignment, though, for some reason, isn't in here. And one of the things, we're not going to build any databases, but I wanted to do a database diagram for our project, and I'll show you what the project's at.
We can see it in assignments, just, yeah, not
but not in the module, yeah. So somehow I didn't get it into the module. Okay, so let me talk about the projects, and then I'll talk about the tools and what these diagrams and stuff look like. I think it might again be in the modules. My modules are in a weird order because the overview is down here. So this is, there are 2 systems that we're going to look at. They're fairly simple. They have more complexities than you might think, but they're still fairly simple. Whereas if we did something really complex, the thing is we've only got 8 weeks, right? And there's that. So what I'm going to do, and it actually is more interesting than it sounds with. So for a lot of the examples that I do in the videos and my diagrams and stuff will be based on basically a card lock thing like this, you know, where you swipe your card and it lets you in, right? So there's a few things in it. People will be assigned cards that can be swiped to doors. Most staff can only open certain doors, right? Because I can open all the doors in this area, but if I walk down the hall, I can't open those doors, right? So people are assigned certain doors, certain things. Most staff can only open certain doors. An instructor can always open their office and the door to the mailroom, but can only open classrooms they teach in, right? And only during the times and dates they teach. And then the department admins can open all the doors in their authority. So the dean can open all the ones that are relevant to their sections. And the IT admin could open all the doors in the IT department. Security can open everything all the time. So you have different kinds of users, right? All card swipes on the doors are logged in a database, which also keeps the status of the door locked or unlocked. And some doors have a higher security level than others. And alerts are generated and sent to security when a door is tried unsuccessfully more than 3 times. A door is unlocked for more than 3 hours, which I don't know if that's true because this door is unlocked for hours and hours. And any failed card swipe on a high security door. And the cards are dumb cards. Do you know what that means? So orcas are smart cards. My card here is a dumb card. What that means is my card here has nothing on it but a number, right? So when I swipe it, that number is sent to a database, which compares the number and then comes back and unlocks the door or doesn't. So there's no information on my card. Have you ever looked? I don't have my phone on me. Orca cards actually keep track of your last 8 trips. They keep track of your purse, how much money you've got. They keep it. All of that information is on the card itself. I have a phone app that lets me look at it. I can see what's on my card. It's just, you know, it's on a chip. So they're a smart card. All the information is on the card. Whereas the door card is just a number. Just passes a number off to a database. Does that make sense? So we're going to use dumb cards for this. People are assigned cards. Cards can be active or inactive, meaning no longer valid. So does that make sense? It's a simple system, but it has some complexities, particularly in differentiating users and things like that. It may not be the most exciting thing in the world. I mean, we could, as I said, it's not like designing a rocket or something. All right, so the individual assignments, and I don't give us quite as much information. I've noticed recently that more and more fast food restaurants are getting kiosks where you do your order at the kiosk. And basically what we're going to do for the individual assignments, so I will do, my examples will be with the locks, but the assignments that you do will be with the kiosks for the food in McDonald's or Domino's. I know they both have them. Actually, the first time I saw it was I was on jury duty in Tacoma, and the only restaurant within good walking distance was a McDonald's. And they had a kiosk in there to order right before you go up there. And I guess Domino's does too. Anybody else know of others? Some Burger Kings do. And so I'm thinking about what would the software be for that. And we're going to make it more generic than just McDonald's. For instance, McDonald's doesn't have any user points or anything. You don't get any, you don't get any discounts, but Domino's does, right? If you're a user, if you register, give your phone number, then they do have bonuses and benefits and things. So we want to make something generic that could be used in a lot of different places. Again, it's not super exciting, but it has complexities enough to give you a feel for it without overwhelming you with, the massive complexity of it. Does that make sense as a project? Anyone object to it? It's too boring? One of the ones I used to do, but it's actually even more complicated, that if you really wanted to substitute, you could, because it's similar, is the grocery store kiosk. You know, when you do self-checkout, it's actually a little more complicated because there's a little bit more going on, you know, in terms of if you scan alcohol, you know, it has to alert the user. If you buy, usually you can't get it to the checkout, but Benadryl or something like that, it will generate an alert. You know, so I mean, that's another alternative, but it's a little bit more complex than this. I was just hearing on NPR today that they're thinking that this will be that basically a lot of the service jobs will go away in the next few years, because you can, if you think of how McDonald's does burgers, robots could do that.
I was going to ask about that. I mean, how do you completely take that away? You've got to have someone there.
Well, so there's, I'm sure there'd be someone there, but instead of having a whole line of people serving up, you know, one person puts the burger on it, the next person puts the sauce on it, the next person. I mean, they basically, it's like a assembly line. Yeah. And, you know, that could be done by machines. There'll probably still be somebody there. And one of the things these kiosks do allow, if we talk about it, they do allow you to customize your order. So there are some differences there. All right. So those are the two basic projects. And again, this one will be for samples, and this one for the assignments. What we're going to use is Lucid Charts, and the only other thing we'll probably need is VS Code, and you don't have to use VS Code. You could use idle if you prefer, and then Python 3.7. Now, I will, if you really want to do it in Java, you can do it in Java. I don't care. But I'm going to use the examples in Python because I know that everyone's probably had some Python. Do you guys know Lucid Charts? All right. Yeah. I'm going to go to Lucid Charts. I think I have it on here. Yeah. It's just lucidcharts.com. Now, this is tempting, but don't do that. When you go to lucidcharts.com, what you want to do is go down to the bottom and choose education. If you do education, you can, and you enter your EDU email address, you get the full featured Lucid Charts for free. Right? If you go for the free, if you go for sign up for free, you get to use it 3 times. And then you're screwed. So, or you get, I think it's possible to get a free version that's somewhat crippled. But if you enter your EDU address, you'll get a fully featured Lucid Chart they haven't limited me. They've had it for over a year.
This tells me you can create up to 10 documents and use up to 100 megabytes of storage.
If you do it just free?
No, that's the student one.
Should be able to do more than that, because I've got more than that.
So to get started, a request quote for EDU premium.
Huh. Maybe they've changed it. That could be a problem.
Yeah, I typed in my Seattle colleges and that blank too.
They gave me, let's see.
It's a little different.
What?
I think it's for people signing up now. It's a little different.
Yeah, 10. That could be a problem, though. We might have to figure out another.
When I messed up and signed up for the 3, I cannot like thing and then I erased it and then.
Oh right.
And then
Sure.
Or just use like 10 different email addresses.
Yeah.
Well, you'd have to have them all be EDU. Well, I guess if you could do like the EDU one and then do a free one.
Yeah.
Or just do like 10 Gmails.
Right.
So you could use like what 3 times 10 30. Yeah.
Yeah, I think that works.
Yeah, this is the issue. I always have to remember my password. So we may have to do something else if this doesn't. But, so you saw my password, but it's okay. Again, okay. So I have way more than 10. Um,
I did too. I wonder if it's just.
I got the same message.
10 of them? Huh. And that's by going through the EDU at the bottom.
Mm-hmm.
10 might work, but you'd have to be really efficient.
I didn't know that the EDU gave you 10, and I was able to make it work with 3 in my database class. I had to like print out and delete old.
Oh, it would let you delete the old ones?
Yeah, so if you deleted it, you just have a max of 3. So I'm sure with this, you just have a max of 10.
That might work. It's a nice program. Is that mine or is that somebody else's? We'll try Lucid Charts if it gives us a problem. They have different types up here, like they have ERDs, entity relationships, right? So we could do that. I'll show you that in a moment. They usually do have UML as a type also.
Yeah, if you get more templates.
Oh, more templates. And what UML is, let's see if I can Swimlane. So
For me, it shows us.
where did you see that?
Mine looks like weird.
Huh.
This stuff at the top.
I wonder why yours is different.
Yeah.
I think if I go over here, though, there is UML. And there are different kinds of UMLs. And it's not actually going up in size when I do that. I'm going to show you some pictures of this. But what UML is it basically over time, different companies have developed different ways of diagramming software. And the UML it's called Universal Modeling language because they wanted to create a set of diagrams that were generic enough but consistent enough to be used across all companies, no matter what you were doing. So they've created, some of it has been much more widely adopted than others. And we're looking at some of the others. There are use cases, which I'll show you some better pictures of in a moment. Sequence diagrams, which can be a little bit clearer than that. Here's a sequence diagram. More use cases. Class diagrams, as I said, basically class diagrams are pretty universal. And we'll talk about those in a moment. I'll show you how to start a entity diagram in a moment. But first, we could look at what the UML is. This is a really nice program for diagramming. I'm hoping that it works for us. And it's available from anywhere on any kind of machine because it's web-based. There are lots of other things you can do. If this fails, I don't necessarily want to do this, but I have accepted hand-drawn things and photographed with their phone. And in fact, when I'm doing something for myself, as opposed to for display, or I often just sketch it real quickly on a piece of paper because it's faster than using diagramming software. We'll come back to this. I want to just show you, so I'm going to do some real quick. So let's say use case diagram. And what I'm going to do is I'm just going to do images, and let's just pick one, and maybe, can I make that bigger? I made it smaller. Why would a plus make it smaller? Will minus make it bigger? Weird. So we'll do these. These are just a quick introduction so you have some idea what you're getting into. A use case diagram looks deceptively stupid, very simple. You have a stick figure who represents the user, what kind of user they are. And then you have basically bubbles or balloons that have a verb phrase in it in terms of how they will use the site. This is one: search docs, browse docs, view events, log in, upload docs, which extends the manage folders. So there's a utility for that. Extends means there's a dependency there. You can't upload docs unless you're doing the manage folders. Same with the preview. There's a preview included and a download docs. So these tend to show dependencies and relationships. You don't have to do a lot of that. The real thing is just figure out what are the high level. That's the other thing about these, is that they tend to be high level uses. You're not talking about getting down to the code and what methods they're calling or anything like that. You're just looking in general, how would a user use this site? Webmaster does post an event to a home page, add user. As simple and dumb as these look, they're really, really useful to get a sense of what's going on. A couple other things which we'll look at when we actually do the assignment is there's usually, each of these use cases usually has a written piece too, which says what the content is and what's involved in logging in, what's involved in viewing the events. So, and I'll show you that, what that kind of looks like, but they usually have a written component for each of those bubbles too. So that was chosen at random here, basically. I'm just choosing from you can see there's lots of use case examples there. And if you've done Agile, as I've said, use cases is a lot like writing stories, because they usually do a story about how a person would use the software based on what, different people. I'm going to do an activity diagram. Again, this is just a quick review of some of the stuff we'll be doing. This stuff can be kind of fun. Activity. I'm going to do that. And these, let's look at this one. These are kind of like a flowchart. This one's a little complicated in that it has a split. So you establish email communication. You can send an email, receive a response. Basically, the split means that these are asynchronous. Does that make sense? So they can happen at the same time. Encrypted email, regular email, communication established. I haven't seen that symbol before, but the time clock. And then you have a decision point, right? It's a lot like a flowchart. And there are lots of them. The other thing that I'll see if I have you can also have what they call swim lanes. We'll talk about that too. Swim lanes are what general area is responsible for those particular actions. Does that make sense? So this is the salesperson is responsible for these, the consultant is responsible for these, and the corporate technician is responsible for those. And that can be useful too. This is, as I said, really quickly, we'll spend time on that. Class diagrams you've probably seen. Which one do we want to look at? Something not too complicated. Random. Basically, a class diagram has like the fields and the methods. right? The name of the object. It talks about, so this one has, it's just storing fields. This has a couple of methods. This has methods, but this is actually an interface. One of the problems with Python as an object-oriented language is it doesn't support interfaces. I don't know what that is. It's empty. But that's what a class diagram looks like. It's basically broken into three parts: the name, the fields, and the methods. The pluses mean public. Minuses, which they have none, means private. That's about as far as you get in a class diagram. But it's actually pretty useful. When they send plans for coding to like India or whoever's doing the coding, they tend to send class diagrams because it tells you exactly what the fields are going to be, what the data types are going to be. It gives you these, and then they might give you some written specifications of what has to happen in those methods. That makes sense? One more type of diagram, just to show you. Oh, I shouldn't have done that. Now I have to go all the way back. Sequence diagrams tell you how the classes talk to each other, how the objects talk to each other. So let's go to the images again. That looks like a good one. Do the first one. So they talk about, basically, these are the different objects, and these are the messages that are being passed between them or within the object. So it basically is tracking what kinds of messages are going between the different objects. That's actually really useful because when you have a code, have you guys done, where you have lots of different objects, it's sometimes really hard to understand how they actually interact and relate to each other. This is really about how they do that, how they interact with each other, what messages they pass to each other, what gets passed back. They look complicated, but they're, and they actually, of the diagrams, they are the most complicated, but they're still not terrible. Okay, so those are the kinds of things we're going to be doing for diagrams. The other thing, the very first assignment is just to do an entity, and I would do like a blank entity. And I'm just going to show you how it works. And let me know if we have problems with this. So if you've never used it before, give you the grid here. These are flowchart things, containers, shapes. The entity relationships are down here. There's not a lot of symbols. Most of you have had ITC 220, right, and did some diagramming. And I'm not going to be too picky about these, but if you were to think about the, and I would use, let me make this bigger. You need it bigger from the back still? That's okay. So an entity, let's just say like user for the logs. Primary key, we'll just say user ID. What other fields would there be? Maybe user name, user email. That might be enough. I would probably get rid of these keys because there is no key there. I mean, that's basically an entity. Let's do another one. I'm going to do like card. I'm not entirely positive these are what I would do, but let's do card. And let's do card number. Probably, and that would be like a PK. And you could do card ID if you want to be consistent. I'm actually going to get rid of, so when I click on this, I can do the number of fields could be 1, and it gets rid of all those others. There's a little dialog up here where you can choose the number of fields. You can also add above, or you can add below, or you can delete one. I'm going to do one more thing here, and then we're going to call this good. I'm going to say user card, because one user could have many cards over time. Probably not true that one card would have many users, but whatever. I'm going to say card number and user ID. And these would be foreign keys. Do you guys remember all of that kind of stuff? If you need to go over it, I will make a video in this too. And then I can do, like, if I want to go, you don't have to necessarily go from field to field, but I'll go from there. And I will go from here to here. Okay. If you want to change these, you can click on them. You can delete them. You can also change the endings if you want. So, you know, you could make it 0 to many. I don't care about that, actually. That's what's called cardinality, 0 to many, 1 to many. This is 1 to many, or 1 to 0 or many. This is 1 to many, period. These are extra. Databases don't enforce them, but they can have logical reasons. Does that make sense? It's really a nice diagramming program. It's fairly easy to use. We used to use Visio, but Visio is a real pain to use, particularly for ERDs. It's not so bad for the UML. It's saved automatically. So it's untitled. I could, if I click this, I can give it a title. So I could call it like lock ERD. So there would be other things on here like the room. The other ones over here, there is like this 3 one. That's useful if you want to have the keys, the name, and the data type. I don't care about the data types right now. We're not actually going to build this database. I just want you, underneath any of these systems, there would be a database. I just want you to think about it a little. That would be the first assignment, which I need to put in the modules there. Questions on anything? So in tools, basically the main tools are Lucid Charts. And we'll see if that gives people a problem. We'll figure out something else. The VS Code is optional. Have you guys used VS Code? Okay. It's nice. I like VS Code. It's a lot lighter than Visual Studio, although you can use Visual Studio if you want. You can also, with Python, use idle, or if you have, what's the really expansive Python suite? There's a Visual Studio-like suite for Python, which I don't remember what it is. But it has so much more. I mean, Visual Studio Code is so nice because it's just simple. It's just the code, the files, and a terminal. I like it a lot, actually. And it's free, and it runs on anything. Do we have it? That's a good question. We have Python. I don't think we have Visual Studio Code, but we can add it. We don't need it for a while, but we can add it. It doesn't even require you to get my permission to install it, because it doesn't write to the my brain is gone, to the registry. It's written in JavaScript, weirdly. Visual Studio Code is all written in Microsoft's version of JavaScript. Okay, so we'll install it when we need to. Are there any questions? So let's go back to the assignments real quickly, and then we'll talk just about what I will do, and then we may call it early, which is very early. So the database ERD is the first one. It's due next week. I will give you next week to work on it, and I can help you with it if you need to, right? I will try to put a video up on it. I mean, there's what I'm doing right now has a video, but I'll try to put up more of a video on doing that and do out the whole lock one, right? The example one, just to give you a sense of that. I will get some videos for each of these. There are videos from last quarter, but again, they're full of me troubleshooting and talking to people and things like that. Does it make sense? Do you think you can make it through the summer? Okay, so the last thing we haven't talked about, the presentations. So let's go back to the modules. So the presentation topics that I have, and I need to adjust these dates. Oh, no, I don't. Except this is definitely not April. It has April, July. So I need to get rid of that. So these are my suggested dates. They're movable a little bit. These are my suggested topics. It is possible to come up with other topics. And again, these are the topics for the things that I am, that are part of the systems analysis, but that I'm not actually going to cover much. So the waterfall approach is the traditional old-fashioned systems analysis approach. It's basically where you start with the planning and work through design, and you go through that process. You do it step by step by step, and then you produce it. One reason why there's so many other approaches is that this one doesn't succeed a lot, but it's still worth going over as to what it is. Agile, that's fairly common. It's still heard it. A lot of adaptations as to what agile means these days, but agile is still a real common one. Yeah.
So we do one presentation like every week, or just one?
So this is like July 17th, so 2 that day, 2. I think I have 3 that day, and I have 2 that day, and I have 3 that day. They are movable to some extent.
I mean, like we individually.
You only have to do 1.
Okay.
Right, so you only have to sign up for 1, and I'll show you in a moment how you can sign up for them. So yeah, you're only responsible for doing 1. You don't have to do a bunch of them. And the ones that don't get anybody signing up for, I'll try to do something.
So you do 1 off that whole list?
1 off the list, right?
Okay.
Yeah, you don't have to do. You're only responsible for 1.
Okay.
It works better. See, last time I taught this last quarter, I had 35 people, so there were plenty of people for all of these.
Yeah.
This time, I suspect if you get 2 or 3 people in a group, there's going to be a lot of empty groups, and that's okay. So you can do what you want, I guess. And if you're alone, if you want to do it alone, might choose one of the less popular ones. I don't know.
Yeah.
Feasibility analysis is part of it. That's basically something before you ever start working on a project. Is it worth doing, right? Is it going to make more money than it's going to cost? Is it going to crash and burn? And so you have to look at that in terms of real, analyzing what does it cost? What are the drawbacks? What are the benefits? Things like that. DevOps, which is it's kind of the current thing. It's even beyond Agile in terms of how they're working on the systems. It's changed the way software is produced. So it's probably worth looking at. This was one I hadn't thought of, but a lot of people wanted to do blockchain. If you want to do a look at that. I'm not interested in cryptocurrency, by the way, just at the blockchain part of it. A lot of people think that it might be the future of how security is done. And other people say that's garbage. So it's something you could look at. Project management. A lot of times a systems analysis class would be taught entirely as project management. If you think about what when you go sit down to write a piece of complex software or do a system like this, it tends to involve a lot of people. It tends to involve time. It involves money. It involves, hardware, things like that. Managing that project is a whole topic in itself. It could actually be the whole summer. It could be you can get a master's I mean, it's a complex thing. And it is a major part of any kinds of systems analysis. It's just not the part I'm interested in is first, but it might be the part you're interested in. So you do that. Service-oriented architecture. Anybody have any idea what that is? It kind of goes with DevOps. You might not have heard of that, but so one of the things is a lot of people are reimagining software as services. If you think a website can be basically nothing but a conglomeration of services, you could pull in a news service. You could pull in a scheduling service. You could pull in a, I don't know, travel service or something, in there. And basically you just conglomerate all these services. Windows these days, Windows 10, is nothing but a set of services. The advantage of breaking it into services, and each service is basically a small independent executable program. The advantage of breaking it up into services is that you can switch them out. Without having to take all of Windows down or something, you can switch a new service into an old service. You can constantly add and update and change things without having to update and change the whole thing, because everything is a collection of different services, and the services are independent of each other for the most part. There's an overarching structure that calls the different services at the right time, right? But software is kind of going that way, and part of the reason that it's going that way is because of DevOps, because it's constantly. One of the things about DevOps, if you take that as a topic, is that it advocates constant updating, constant deployment. Rather than the systems process is continuous always. You're always updating, you're always changing, you're always doing it. Which can be kind of a pain if you're a Windows user, actually. Is there updates like every day? So that's what SOA, service-oriented architecture. Last time nobody did that. Programming patterns. If you're really interested in object-oriented programming, these are patterns that are above just classes and how classes relate to each other. They're kind of the next level up. Most of you have encountered at least one model view control. Have you done that? So most websites are kind of built on model view control. The model is the data layer, the database. The view are the web pages, and the control is to get the data from the database to the view, to the web page. And also, the controls are to get the data from the forms on the web pages into the database. So they're the control is the link between the data and the view. That's a model. That's one model, is model view control. There are lots of others. There's like a Sentinel model where you have a class that just hangs there and constantly pings the other classes and waits to locate a change. And if a change happens, then it causes other things to happen. So it's just, you have a model where you have basically a Sentinel that's constantly pinging the other classes to see what's going on. Anyway, it's kind of interesting if you're really into higher level programming. The reason that they exist is that these patterns can be applied to a lot of different situations. So they give you if you look at a situation, you can say, oh yeah, we could do that. We could apply that pattern, and it gives you a heads up as to where to start at least. Another pattern which uses a lot in games is factory pattern. Basically, you have a class whose purpose is to produce other classes. So you have a game that produces tanks. You have a factory class that produces tanks. Things like that. This is kind of to this aside, but with systems nowadays, there's a lot more. You have to integrate different kinds of databases and different things, and NoSQL is becoming very common. So just an overview of the NoSQL databases. It's not as directly touched as it could be. And then a little bit about data analytics, which could be a part of the systems process as you analyze needs and things like that. We are, by the way, side note, we're hoping to do a data analytics certificate in the next couple of years, probably might even be starting in the fall. There's a lot of demand for that. We decided data analytics because not data science, because data science usually requires a PhD. But data analytics is basically where a business is asking you to do take database data from various databases, analyze it, look for patterns, things like that. We'll probably use Python. You can use Python or R as the analytic language. So these are, as I said, they're group assignments. If you go to people, and there are groups, and in the groups, come on, show me the groups. Are they not there?
No.
Why are they not there? I will add the groups. They were there last quarter, and I copied this from last quarter, so why is it not there? I will make a group for each project. All right, and then you can sign up. They're not there yet. Are they there if I do? No, the groups are not there. They did not get copied. All right, so I will make the groups. I'll do that this afternoon. But when they're there, I'm going to let you self-assign. So you can just say you want to join a group. Yeah.
How many people are supposed to be in the group?
I will set it for probably a max of 4. Does that make sense? I usually find, in terms of groups, it's kind of like with the Apollo program and things. The ideal is about 3. 3 people tend to work together. They tend not to hate each other. Get into 4, and there's oftentimes one person that doesn't do much. Get into 5, and it's like 3 do most of the work and 2 don't. Or you get like what they call a minority opinion. You get 2 different groups. Groups tend to fracture the bigger they get. And that isn't always true. I've had some big groups that work just fine. 2 is kind of minimal in terms of, but I will let this class is small, so I'll let the groups be whatever they are. But I'd rather that it wasn't like 5 on one topic. If you really beg, I might allow that, but that means with as many groups as there are and as few people, there's even more that aren't covered. 3 is usually the ideal amount in terms of working in a perspective. They actually did prove, did a lot of psychological studies too to say that 3 was like the ideal amount for going to the moon, living in a confined space, because they weren't likely to pair off. I mean, if you had the animosities tended to keep less. So I will add those groups. There will be a group for each thing, and as I said, the due dates are somewhat movable, but I don't want to do them all on the last day. So one of the ways to look at it, if you look at, let's go back to modules. If you want to do, get it done with early, you could do one of these. If you want, the last one I have is August 7th. What is our last day? I think it's the week after that, right? Mm-hmm. So the very last, it could be moved to be 1 more week. But, like there's 2 on the 31st, 1 on the 24th could be moved over or something if need be. 24th is already full. I also want to leave you time enough to do Open Lab, to work on things. Couple other things about these presentations, and then I'll be done, I think. I'm not looking for huge depth. I'm looking for an overview. I think I give some of the things in the assignment. Basically an overview, advantages, disadvantages, just a quick, I'm looking for like 15 to 20 minutes max. 15, I don't want to, any one of these topics could take hours. Right, I just want to hit the highlights, overview. What is this topic about? How does it apply? And then, benefits, problems, move on. Is that okay? So I'm not asking for deep things. Like you don't have to show me the programming code for blockchain if we do that. I actually know what it looks like to some extent. It looks a lot like a linked list. You know, so these shouldn't be that long. If you really hate presenting, which I hate presenting, even though I'm up here all the time, I understand. I also always hated groups, but in the real world, they do a lot in groups. Almost all programming is done in groups. So, or at least you have to meet with groups fairly frequently. And this is a very small, friendly audience, and I suspect as we get going, it'll be smaller and friendlier. So it shouldn't be too terrible. And again, if you can't be here, just I'll present if you send me a presentation. That being said, don't everybody not be here on their presentation. Anything else? I said I assume we'll start for real next week. It's going to go fast because there's only 8 weeks, and after this there'll be only 7 weeks. Yeah.
I have a question about the homeworks.
Yeah.
If we submit it ahead of time, so
It's perfectly fine to submit it ahead of time. It's also, probably shouldn't say this, but I don't care if they're submitted late either. I don't take any points off for lateness. That being said, please don't turn them all in on the very last day, because it makes my last.
you want it to be submitted GitHub or
No, well, so for the most part, just Canvas.
okay? Like you want, I don't want Canvas, but you want like a link to GitHub or like,
So if you do the diagrams, so one of the things you can do with the diagram is you can share that with me and just give me the link for the share.
because what I'm personally thinking of is just create a folder in a GitHub.
GitHub would work
And
too.
get all that stuff done in it and submit one link for all of them separate. Like submit it into Canvas where you can access that link.
That would be fine. That would be fine too. So GitHub would work. You can also link, as I said, you can link directly to the diagram from Lucid Charts, and I can share. I've done this in the past, and it works really well. If you want to do it in GitHub, that's fine too. So GitHub, or as I said, when you do the diagram in Lucid Charts, one of the things is there's right up here, share.
Okay.
And if you share it with me, all I do is I click on it and it opens up the diagram. So it works too.
The only reason I would want to do GitHub so I can, build.
That's perfectly fine. GitHub is fine too. And just a link to it. As long as if it's a private repository, make sure that it's shared is all. If it's public, it's fine. It doesn't matter.
No, it is public.
Yeah. With coding, I do have people do it through GitHub. The charts, you could do it you could do it though.
I was thinking of the folder in the PDF file.
You could do that. You can make a PDF. One of the things you can do with these file, there's I think you can do a save. Well, I think it just saved it locally. Make a copy, is that it? No. I know you can output these as PDFs.
Download as.
Download as, yeah, PDF, PNG. Yeah, so you can do that. That works. And if you don't want to share you can just do that too. Just make a PDF and turn it in. Or PNG. Canvas is actually pretty flexible with what it'll load. Weirdly, the thing it seems to have the hardest time loading is plain text. If you do like a notepad file,
Yeah.
it takes forever to open. Whereas Word or Excel or something like that, it opens instantly. So it's strange. Other questions? And I wouldn't swear that I've covered everything, but I've tried to. And I'm going to kill it now, but all of this is on a video that I will